Okay, here's another trig equation thing. We're looking, they ask the question slightly different. It's very much like question 3. It says f of x equals this cos x minus 30 and g of x equals sine of 3x. So what you can do is they say solve for f equals g. In other words, where do they cross each other? Well, we just need to find the general solution of this equals this. But instead of the sine of 3x, we know it equals the cosine of 90 minus 3x. Well, there you go. The only way this could be true is if x minus 30 equaled this 90 minus 3x. But with cosine, we have two answers that give us the same answer, the positive and the negative. Well, let's take a look at the positive first. We'd have x plus negative 3x, that'd be minus 2x. Then we'd have this negative 30. We'd add it to, oh, sorry, I just did a little bit of a mistake there. Look, we got 2 here. Don't get confused. Maybe you should write out both separately. You've got plus 30 minus 3x. You're going to have to add 3x to both sides, and it turns into 4x. Scratch that last thing I said. You add 3x, and you get 4x. And you add 30 to both sides, and you get 120. There you go. And you divide by 4. 4x divided by 4 is 30 degrees. And 360 divided by 4 is 90 degrees. So there's your general solution. X equals 30 degrees plus k times 90, and k is an element of the integers. But the other answer is x minus 30 equals negative 60 degrees. Minus 3x is plus 3x. Now that plus 3x, you take away 3x from x, and you get minus 2x. And here you've got minus 90, there's minus 30 here. You add 30, you get minus 60. Now divide by negative 2, and you get x equals 30 degrees plus k times 180. You're thinking, oh, maybe I divided by a negative. This plus should turn into a minus. Well, you could write it like that. It wouldn't be wrong. You see, because k is a positive or negative integer, you can just write it like this. It works the same way. Because k is plus or minus or 0. So there's your two general solutions. Now the thing is, if we've done this right, these two graphs, when we graph them, should equal 30 degrees, should be one answer where they cross each other. 120, they should cross each other. At minus 60, they should cross each other because that's minus 90. And maybe, well, we'll see, because they just want us to graph between minus 90 and 120. So we're going to sketch the graphs now. Now, how do we do that? Well, let's take a look. Let's first look at the sine 3x. Dividing by 3, we know the period is 120, and every 30 degrees something special happens. The sine of 0 is 0, but at 30 degrees, the sine of 3 times 30 is 1. Then it goes back to 0 at 60, and then down to minus 1, and then up to 120. You don't need a calculator. It carries on in this same pattern. You can put minus 30 in there and get the answer out as minus 1. But you know it goes down, comes back to 0, and it ends up here at minus 90 and 1. Make sure you label the turning points and the end point here. Okay, so there's 3 marks for that one. Now the cosine of x minus 30, you have to know that cosine normally goes through 1 and then 90 degrees. But when you subtract 30, you translate 30 to the right. You go to the right 30. So 30 degrees in 1 is one answer. Then 90 degrees later, it goes through 0. 30 minus 90, at minus 60, it goes back to 0. And then we have to figure out what it is at the end point. So when we take minus 0 here, when x is 0, the cosine of minus 30, it's 0.87. We have to label that because that's an intercept. And down here is an endpoint. So just put in minus 90 minus 30, minus 120. The cosine of that is minus a half. So you have to label that endpoint. And label it F. There's your 6 marks. Now this is a calculus thing we haven't quite got to yet, but question 4.3, what they're saying is, we don't know that when there's the derivative greater than 0, we don't know what that means. But when the derivative is greater than 0, what they're really asking is, where, when you're moving from left to right, is it getting bigger? where is it G increasing? So here's G. Look, it's getting smaller and smaller and smaller and smaller and smaller. Now it stops, and now it's getting bigger and bigger and bigger. The question, when you see this, it's calculus, but all it means is, when is it getting bigger as you go from left to right? Well, it looks like between minus 30 and 30. Now it's getting smaller, and then from 90 to 120, it's also increasing. You don't put lines underneath. So there's your answer to that question.